Well, hello everyone, and I'm pleased to be talking with you today. I frankly would rather be talking to you from maybe the 19th hole at the Firestone Country Club here in Akron, Ohio. I have had a chance to visit this beautiful course and beautiful city multiple times to Akron. One time to the country club. That giant golf ball on a tee there that you see, I believe it's a water tower, although it would be a good location for a wireless setup as well. But unfortunately, we have business to do, or maybe fortunately, we have business to do. I think this is a pretty exciting topic. We're going to talk about LTE Narrowband IoT, global standard, now operational on the upper 700 megahertz A block, and how this has progressed. My role here is really to do an introduction. I think you're going to be much more interested in hearing about the applications, and that will be coming up here very shortly. I did want to quickly, though, do a review of the upper 700 megahertz A block that's represented in most of the Region 4 by Select Spectrum, and we have a significant, well, our host for this Region 4 is First Energy, of course, and they are a major user in this band. So briefly, I want to review the existing solutions for the upper 700 megahertz A block. This is really what has been, the key use of the application so far, and that's why we developed the original solutions. That's what our original customers have done. Then we've added the new capability, LTE Narrowband IoT, and that's what we'll be talking about mostly today, or at least that's what the rest of the presentation after my portion will be discussing, is why this is relevant to members of UTC. And then finally, we'll talk briefly about an RFP that we ran that was won by Puloli, and you'll hear later from Kethees talking about what they've done to implement the requirements of that RFP. So the upper 700 megahertz A block is now familiar to many of you. We sit between Verizon's national LTE deployment and AT&T FirstNet's deployment. We have 1 by 1 megahertz. It can be used for fixed or mobile. It's been recommended by UTC in a white paper. And as shown here on this slide, it's been implemented by a total of 19 utilities. We've had additional buyers from the automatic train control application for California high-speed rail, for oil and gas, and for UAVs, drones. So very significant. These deployments now cover about a third of the population of the country, which including a significant portion of Region 4, and we are in the business of marketing those for other users. You'll see here a wide range of applications. Generally, I call these wideband applications. These are industrial grade radios, highly secure, highly efficient, and designed for really critical infrastructure implementations. So this has been successful, but we did want to also think about other potential uses for the upper 700 megahertz A block. And with the rapid acceptance globally of narrowband IoT as part of the 3GPP cellular standard, we said, well, what about the ability to do NB-IoT? Here, by the way, on this next slide, we'll show you the coverage of the upper 700 megahertz A block. It is quite significant in terms of what's already been sold. Those are the darker colors on the screen. And in addition, there are the lighter colored areas, light green and light blue, which are still available. So please talk to me about any of these areas in the light green. Talk to John Vislowski at Access Spectrum on any of the areas that are light blue. Those are still available for purchase. And we expect that over time, with the variety of applications, that these will all be in use by various critical infrastructure companies. So in terms of radio suppliers that serve this band, we have over a dozen that are serving the band. First of all, for these industrial grade radios, for example, General Electric has been selected by First Energy. We have significant deployments from all of these other companies as well. And so we're pleased to have this full set of options for users. The primary use has been in wideband data networks, and we are, in addition, we have the availability for land mobile radio, and it's been used also by leading suppliers that support the UAV and drone industry. So why add NB-IoT when you've got all these highly capable, effective systems? Why add these as well? Well, the reason is there's different ranges of applications. So NB-IoT, as you'll hear more completely in the remaining portion of this presentation, supports very long range. You can operate on a battery system only, and the very low cost per remote. We're talking chipsets at less than $10 for the chips. These can be massive deployments. They can support rapid provisioning. You know, this is designed for the cellular industry, and this is an industry that supports billions of endpoints, literally billions of endpoints nationwide, and implements millions on a daily basis. So this is highly capable, and it makes it effective for utility deployments where, you know, you can't necessarily afford an expensive solution for every application. And this is something that could support a wide range, as you'll hear later. The frequency reuse in NB-IoT can be N=1, meaning you can use the same frequency at every cell site. And you know, besides all of these sort of technical advantages, it can fit into an LTE corporate strategy. If your company has decided that LTE is and 3GPP and 5G standards are the direction it wants to go, then you know, this can fit into that requirement. So we issued about a year ago, and I'm sorry, 2 years ago, an RFP. We pretty rapidly selected Puloli out of a number of bidders, and you'll hear later from Kethees talking about the Puloli implementation. We thought about a range of sensors, and you'll hear more about what some of those applications are. But generally, the concept was lower cost, lower bandwidth, lower throughput type applications, which could be broadly deployed. And JEA was selected as the initial utility customer in Jacksonville. Our goal, by the way, was to serve the Jacksonville MEA, serve their requirements, and also get the license renewed, which we were successful at doing all of those. And while their first applications were for emergency generator performance and remote temperature sensing, you'll hear about one other very significant application today, and there's many more planned, is our understanding. So really, this can be a network that serves multiple applications. With that, I want to say thank you for the opportunity to present this to you today, and you'll be hearing from my additional colleagues.
Hello, everybody. My name is Kethees Ketheesan, and thanks for the introduction there. I am the CEO of Puloli, and I am going to talk to you today about the utility use cases based on the NB-IoT system that we have deployed and operating in Florida for the past 1 year. Last year, this time, Bob Finch and I were in Grand Rapids, Michigan. We presented to you the first ever private LTE IoT network, purpose-built for utility in the world. We launched the network back in June of last year, and in September last year, we presented the initial use cases and the network design and some of the specifications around it, and we gave you some overview of that technology. And that time we told you this year we will be launching new use cases in addition to the initial use cases that we launched last year. So we are here today going to talk about some of the specifics and some of the details around those new use cases that we have launched this year with JEA in Jacksonville, Florida. So first, a quick introduction to Puloli. We are a network-as-a-service company. We offer fully integrated end-to-end private IoT networks for critical infrastructure, and we are primarily focused on the LTE 5G IoT standards, and so by definition they operate on the licensed spectrum. And in this particular case, we are focused on the upper 700A block that Bob Finch referenced earlier. And key differentiator that we offer to our customers is that we design, deploy, and operate and manage the network on behalf of our customers. And that has a lot of benefits and an advantage that utilities can take advantage of, and we will touch upon some of the specifics later. So a brief introduction to NB-IoT. That's NB stands for Narrowband Internet of Things. It is part of the family of standards, part of 3GPP, LTE family, and it is also a part of the 5G portfolio of standards that's going forward, being continued to be supported and evolved in the 3GPP standards body. It is designed for long range. It is designed for coverage and deep indoor penetration to support various applications that are very, very difficult to sustain and operate on the standard broadband LTE. It is also optimized for power so that you can have battery operated endpoints that can last anywhere from 2, 5, and even 10 years in some cases. It is based on LTE standards, so you get this LTE security framework. LTE is so the 2 layers of encryption and ciphering protocols that are inherent to LTE that also carries over to NB-IoT as well. So the system is pretty secure, and the reliability and robustness are further enhanced by some of the specific channelization and link level adaptation that has been made to extend the range. So for example, compared to the LTE broadband, it has extra 20 dB of link budget available to do various extended range and robust link management. That comes into play later on when we talk about some of the specific use cases. And last but not least is the ecosystem. It is based on the LTE family. So we have a large number of chipset suppliers who provide a pretty cost competitive offering that we take advantage of. And that is an essential differentiator for NB-IoT compared to other IoT options that these utilities have in front of them. I also briefly want to mention the ease and the rapid installation. That comes into a focus further in the description of the use cases, which is a very big deal because when you want to deploy and manage thousands and thousands of these devices, provisioning and management has to be simple and easy to do, and has to scale with the solution. And also, as a by the way of introduction, wanted to give a global perspective of where the IoT world is today. So in terms of the NB-IoT and LTE-M, you can see in this map, that's a pretty global, pretty rapid adoption for these standards, given they are pretty new and still nascent in many ways. Here in the US and Canada, we have both NB-IoT and LTE-M. LTE-M operates in a little bit broader bandwidth, requires a minimum of 1.4 megahertz, and NB-IoT requires a minimum of 200 kilohertz. So here we have both systems. In many parts of Europe, they have both systems as well. And you can see that in terms of plans and trials, there are quite a bit of activities going on all around the world. And we expect this to continue to evolve. This data is actually almost a year old. We don't have the latest one for this year. We expect that to have further more color coding to happen over the last year, COVID-19 notwithstanding. And then in terms of the device ecosystem, this is equally important from a utility point of view. You want to make sure you have a robust and healthy ecosystem that underpins this vendor suppliers ecosystem. So we have We can see from, this is also from the GSA, this data last year, this time they published this. You can see a large number of vendors supplying the underlying chipsets. Many of them have NB category NB1 and NB2 supporting. There are two variants of NB. NB2 is the latest one from 3GPP release 14. There are also dual mode chipsets quite prevalent. Almost 30 to 40% of those chipsets support dual mode. So in terms of where do those chipsets go into, vast majority, as you would expect, go into the modules that are essentially attached to sensors and endpoints. But there is also a significant number of asset trackers and various other gateway routers for edge compute and edge gateway purposes. And then lastly, the ecosystem as far as the module manufacturers. There you see on the right the big five. And you will see in a few minutes that our ecosystem for 700 megahertz is going to be supported by a majority of these global manufacturers. So that's a good segue to this slide. So this is the big series of announcements you have seen since we presented to you last year in Grand Rapids. So when we launched the network last year, we told you Sequans chipset and the PyCom module were the anchor, the launch products that we did the system launch, the system operation in June last year. Subsequently, this year, you would have seen our press release where we announced a Qualcomm partnership where their flagship chipset, the 9205, is now certified for interop with 700 megahertz A block. And then based on that 9205 chipsets, a bunch of different modules made by Sierra Wireless, Quectel, and Telit are currently undergoing interoperability testing and regulatory approval. We expect to make some announcement imminently, two of these three pretty soon. So that will add a healthy set of new modules that's coming into the picture here for the 700 megahertz A block, which leads to the further right to further down, so this huge multiplier effect on the endpoints. Again, going back to the very top, last year in June, we launched the Jacksonville network with RU700A deployed in JEA. And that continues to be still is the most deployed unit, but we are in advanced discussions with few off-the-shelf endpoint manufacturers who provide not only the device but also the end-to-end application. And we plan to make some announcements and deploy some of these things as part of the use cases in some of our early networks on 700 megahertz. So this falls into anything from advanced engine diagnostics, generator diagnostics, preventive maintenance, a lot of AI algorithms that can be run on these network, on these end-to-end applications for a lot of this predictive maintenance. There are also a lot of sensors and applications centered around those that are in the works that we will be announcing soon. We are also in conversations based on the Qualcomm 9205 chipset, various vendors supplying streetlights, next generation AMI meters, and definitely some of them in the automation and the DER and renewable energy world. So it is exciting time. Once we have these modules launched, we expect a large number of them to announce support for 700 megahertz A block. And a little bit briefly, build upon some of the information we talked to you last year. This is fundamentally the same design, but we have obviously the number of endpoints and the ecosystem there has grown quite a bit. And also we have more data flowing into the end-to-end application based on some of the new use cases that we have launched. So just to refresh, fundamentally, the network is anchored with this Puloli eNodeB base station that sits in the shelter on the base of a tower or rooftop structure with the antennas and radio heads from Puloli going on the top of the tower. We typically try to, as much as we can, possibly go on the utilities towers, because most of the utility customers have quite a few assets like this at their in their service territory. So we wanted to take advantage of it. And from the shelter, there is a utility backhaul. Typically, a fiber goes back into their cloud and the data centers, where the EPC can be hosted in on-prem, or as well as in the shelter in the appliance itself, in some cases, if that's required for security and IT policy reasons. And then from the EPC cloud, the data goes into the head-end systems owned and operated by the utilities and IoT platforms for various command and control and monitoring activities. We talked about the 25-mile going back to the radio interface. We talked about the 25-mile radius. We have verified that and tested that in the Jacksonville deployment, as well as in Tallahassee, Florida. And we're going to talk a little bit more about the details in terms of the planning the network for coverage and then migrating that towards a capacity-centric design. The Puloli base station and the radio front end are capable of supporting a broad frequency range, as you can see there, from 450 to 2.1. But for today's presentation, we are focused on the upper 700A block. You have seen various versions of these diagrams in the past. Just to re-emphasize, we have the bragging rights to be the world's first in terms of a private LTE NB-IoT network built and operated for a utility on a standalone mode in a licensed spectrum, in this case 700A block. So as far as I know, that's the very unique. We are the first and so far the only one that's being operating such network anywhere in the world. It's a 25-mile radius sites, 2 locations on the JEA service territory here, which covers a good part of their service territory in Duval County, and it touches upon a couple of other adjacent counties as well. And we have been able to launch the use cases based on just 2 locations that we built last year. Okay, now moving on to the use cases. The bottom 2 use cases were the launch use cases that we did the beginning of the network launch last year. So just to briefly summarize, we have ambient condition monitoring that does temperature, humidity, and pressure, and has a reporting cadence of 15 minutes. And then on the right, you see the generator monitoring, where it is connected through a CAN bus interface. You see the Yagi antenna sitting outside with the remote unit inside, connected to the CAN bus interface on the generator panel. It also reports on a 15-minute cadence. The idea is to report engine vital statistics, both periodically as well as on demand, on power on and so on. It is the idea, obviously the benefit ROI is to reduce the truck rolls and more importantly, do some preventive advanced diagnostics on the generator. But today, the focus is going to be the top one, the water pressure monitoring. I'm going to go into more detail, but fundamentally, the value proposition for JEA is that they have already made the decision, even before NB-IoT came into the picture, to deploy as many water pressure monitoring sensors on the water lines all over their service territory as many as possible. And the idea is that they wanted to generate, this is brand new, it's still happening. The idea is to do portable water safety alerts. For example, it's common cases where you have boil water alerts sent to the customers when there is a risk of water contamination. So by measuring the pressure at a sufficiently large number of points around the distribution network, they are able to figure out where and when they should issue these alerts based on the pressure drops. As likewise on a predictive maintenance, detect any of the long-term water leaks and anticipate any of the pending breakages, so that you can do preventive maintenance. And even in the case when breakage happens, you can immediately isolate where the fault is based on the pressure changes and the pressure variations. Likewise, there are plans to do consumptive use permit for water water reservoir usages in various parts of Florida. This is also going to be based on the differences in the water pressure changes over a period of time. So currently, it is reporting in a much more frequently than it will be in the longer term, because essentially when we launched the use case, we wanted to get as much data as possible. So it's reporting every 2 minutes. But the long-term plan, we are in discussion with JEA to put some much more programmability into the endpoint, so that you can trigger on events, trigger on demand, and trigger in addition to having periodic reporting. So this is essentially a PLC function now being implemented in on the remote endpoint. The other point we want to make sure is that this is one of the requirements for JEA and other customers around the country, is that we want to ensure this is carrier grade. So we have a lot of measurements about radio link reliability and availability, and I'm happy to report that we are at or above some of the carrier grade statistics that you would expect from a cellular service provider. So a little bit more into the details now. So this is very important to understand the problem statement and the solution, how it came about, so that then we're going to talk in terms of generalizing this to a much more broader sets of use case in this category. So first of all, there's thousands of locations the utility wants to install in the service territory. So that anytime you're talking about thousands of these locations in a small area like Metro Jacksonville, a Duval County, that's a pretty dense, relatively dense deployment. And the current before NB-IoT and Puloli came into the picture, the default the first look was to look at existing SCADA infrastructure. The challenge obviously is it's very expensive when you have to do this many of them, and in most cases the SCADA is not even an option, because in many places there is no access to power and there is no existing SCADA PLC infrastructure to connect to. And also there is a requirement, a need to also put these monitoring systems in a non-utility owned locations. So for example, behind a large commercial building where there is some big water distribution line dedicated to that premise, you want to be able to monitor that as well. So all of those reasons, existing SCADA doesn't really work. So the solution is to use an NB-IoT based long-range network up to 25 miles and use a low-cost endpoints with battery option. So that's the key requirement. And then obviously, as stated earlier, it has to be relatively compact, quick and easy to install, and configuration and management has to be pretty straightforward. It needs to scale to thousands of these in an area like Duval County. And then you need to think, you should not be thinking twice about, let's say you had identified a place to put it in. You can't want to think about whether you're going to have a network coverage there or not. You say, okay, I need to put it in there. You just put it in there, it works without any kind of network reconfig and any kind of changes to the network. So this diagram graphically captures the what I was just describing. This current option versus an NB-IoT based solution. So on the left, you see kind of the legacy option where the sensor typically connects to a PLC through a long cabling that typically, in many cases, you have to break concrete to run those cabling from the sensor to where the PLC is. Typically in a panel that sits outside the building or inside the building, and then inside the panel they usually have the SCADA, the aggregator, and the front-end processor in the same cabinet, where you connect that to the SCADA, and then the SCADA radio and the external Yagi antenna typically is sitting outside the roof in that structure connects to that. From there, it does a short hop. Typically, does a short hop to a local utility-owned tower location where it is received, and then from there might be another hop, or maybe go straight into the shelter where there is an aggregator and a concentrator that takes the feed from that and any other nearby SCADA units, and then aggregates them and sends them over to the backhaul to the SCADA servers in the data center. So that's typically the state of the art today. So obviously it doesn't scale, as I mentioned earlier. So on the right side, you see the NB-IoT option. Pretty straightforward, simple. You have a compact, small endpoint that attaches to the sensor in the same way as it does in the PLC case, except it can be pretty close to the sensor. It doesn't require any special installation requirement. Just find a place to attach it and connect it, and off you go. And then it talks up to 25 miles away to an NB-IoT radio head and antenna. And from there, it goes down over to the utility backhaul to the IoT platforms. No need for any aggregators, no need to do anything custom, no need to configure anything in there. You connect you power on the endpoint, data starts arriving in the IoT backend. So the table below summarizes what I was just talking about, the pros and cons of the solution and why it is finding there's some excitement and enthusiasm in doing NB-IoT use cases for these kind of problem solutions. The traditional SCADA versus NB-IoT. So what is the main lessons learned from this first use case? Because it's not only it's generating a lot of interest and enthusiasm within the utility, but also there are lots of other similar use cases people have been discussing and saying, what else can we use this for? This is interesting, that this is scales well, this is exciting. What else can we use this for? So essentially we try to capture that here. So we summarized some of the key characteristics that have gotten a lot of traction. And we think this is applicable to many different utilities around the country and actually around the world, to that matter. So it's essentially solving the unmet needs and also being in a position to solve the emerging needs, meet the emerging needs. And so that's the key characteristic. So let me see if I can quickly go through this. As I briefly mentioned, it needs to address a large number of locations and large number of assets to be monitored. It needs to scale. It has to be a quick and easy install. It can be a complicated configuration management and a lot of training of the installation crew. That won't work. It has to be simple and quick. You cannot rely on any other infrastructure. You cannot assume, even in some cases, you can't even assume there's a power availability for the endpoint. And then you should not be thinking twice about, if you are in the service territory of the utility, you should not be even have to think about whether you can have a coverage in the location. It has to deploy anywhere and everywhere that is a service territory and without any network reconfig. And be able to put in a facility that's not owned by utility, right? So that's very important as well. And and then the endpoint has to be low cost. We are repeating that message here and again. That's a very important recurring theme because that goes into scalability. It goes into the size of the unit. It goes into the robustness of the end-to-end solution. And then programmability is equally important because essentially, if you don't have the PLCs and the SCADA in the traditional sense, you need to have a programmability and control in an alternate way. So essentially, in an all software PLC approach, some people call it edge compute, some people call it soft PLC. Either way, the idea is to have programmable control about how the data coming in, how to filter it, how to sanitize it, how to aggregate it, and also how do you put conditions and criteria event-based such that you can trigger on certain events in addition to the periodic reporting. So all of this needs to be programmable, and that is a requirement from endpoints. We talked about being a private, dedicated, secure, reliable. That goes into having a licensed spectrum and having a carrier-grade solution that is based on a global standard, which is 3GPP-based NB-IoT in this case. And last but not least, the ideal traffic profile for these use cases is what we call telemetry type traffic profiles, where you send a burst of data every now and then you go to sleep when you don't have to do anything else. So kicking this back up to 200,000. So based on these characteristics, what are the categories now that's now have opened up for NB-IoT based on these lessons learned in this past few months? So the obvious is to repeat myself a little bit here, water and gas distribution are the top of the list because Those are the ones that are the most power constraints and currently not very well monitored in a large scale. And then there's a need to monitor and manage the systems better than what they are right now. So that goes without the saying. And then the second one goes back to the first two use cases. There are a lot of assets that are currently still offline and not monitored by any system today. So they are ideal candidates for this. DER is an emerging category. It goes without saying that's a big proliferation of endpoints there. Again, anytime you have a large number of endpoints that has to be deployed in a constrained environment, has to be low cost, potentially even operating on battery, that's where you have NB-IoT coming in handy. Environmental sensors, we talked about briefly some of the, this goes into if you want to do a gas leak detection or an ambient condition detection, air quality and all that. NB-IoT, again, it's probably the best option given the traffic profile and the cost of the sensors and the cost of the endpoints. Wildfires happening here in the West, as you all know, that's in the news. Whether you want to do seismic telemetry for earthquake management, detection and early warning, fire detection and for early warning on the fire management, all of this, if you want to have remote, large number of devices very far away and very remote, has to be operating on battery and has to be done on a low cost and largely highly scalable way. Repeating myself, again, fits into the NB-IoT use cases. Physical security, another obvious one, building security and many other secondary adjacencies that are currently not monitored. You can throw a sensor and monitoring devices. This is an interesting one. We have been running into this in the past few months, where if you are a utility, you build a network, let's say on a 700 megahertz A block on NB-IoT system. Any excess capacity you can have, you can turn yourself into a service provider for other utilities in the area, municipalities and cities in the area. So this is an intriguing possibility that's now being discussed in some places. We think Puloli, being a network-as-a-service neutral host, can facilitate this in a much more seamless way that doesn't have any challenges with the local utility commissions and public utility commissions and regulatory bodies that govern the utility services in those regions. And then another extension of that, this has also been coming up, is the behind the meter services in the home area networks. Everything from demand response to congestion pricing to advanced monitoring of residential and commercial properties. So all of this is an exciting possibility. The common denominator across all of this is what I told you in the previous slides, the key characteristics of this first set of use cases that has gotten a lot of excitement and enthusiasm. So we generalize that and then reverse map it back into everything else we heard. This is a good category of use cases. The next two are fairly obvious and common sense, so what we call next-gen SCADA and the next-gen AMI. I think the audience know exactly what those two are. SCADA and AMI are well understood phenomenon, so I won't go into too much detail, but what I briefly say, other than saying that we expect most of the advanced metering infrastructure to migrate over to NB-IoT. It is already happening outside the US quite a bit, in China and many other European countries migrating towards this, if not already. I think we expect this to be the case here in the US as well. So if you are a CXO in the utility, what this all means for you in terms of bottom line, right? So given the COVID-19 experience, the need for automation is becoming even more greater and more realized, much more in a stark way. So only way you can do that if you scale the monitoring and the data. If you don't have the data, you can automate. So only way you can get the data if you have a cost-effective, scalable solution. Cost containment, again, goes without saying. If you wanted to monitor these systems in a way, in other options, it's going to cost you a lot more money than private NB-IoT solutions like this. And diversified revenues, we just touched upon the WAN services and some of the HAN services. They add additional revenue options. Sorry, went back too fast. That can substantially increase the financial outlook for the network engineering groups. potentially even migrating from what is typically a cost center into a profit center. That's a bit of a long way out. It doesn't happen often overnight, obviously, but it lays the foundation to get there with an approach like this that you take with NB-IoT on these license spectrums. All right, so I'm going to shift gear a little bit, go back to a couple of things that we didn't really cover in much detail last year presentation, but it's very important to re-emphasize the big benefit of using an NB-IoT solution compared to other options you have for 700 megahertz. Fundamentally, because what you're getting is a cellular system. And fundamentally, cellular, typically when you launch a network, doesn't matter whether you are Verizon, AT&T, or a utility. Essentially, you start with a coverage-based design. And NB-IoT in particular, you can see that we start with a three donut rings, so to speak. And in the IoT world, they go by normal, extended, and extreme. So normal meaning you can achieve most of the link performances in terms of throughput and latency in those coverage areas. Extended means your throughput goes down, but not a major degradation. And then extreme means you can still have a robust link, but the throughput, you sacrifice throughput, obviously, but the reachability is still there. The devices still can be communicating to the network, but you have somewhat restricted in terms of what the throughput can be achieved and potentially some longer latencies as well. So typically that's how you start a system initially, and then as the number of devices ramp up, you switch, the model shift to what we call a capacity-based approach. In the capacity-based approach, you see the system is more optimized to sustain a lot more devices and a lot more throughput. And you will see most of these things fall into normal or extended mode at that point. And then, and there is a fine balance we can strike between the two. I don't want to call it extreme, but two of these edge cases. And then the compromise is where we come into play, where we take care of the migration from a coverage base to a capacity base, because we do the whole thing as a network as a service. We take the challenge away from the utility and we take it on ourselves, and we manage it in a proactive way such that an optimal balance is struck between the two extremes. So this will change over a period of time as the utilities traffic on this network increases. But this is an example just to demonstrate how these two can be blended to have a selectively add capacity and maintain the network in an optimal state relative to the offered load. I wanted to emphasize this point because this is one of the big benefits of the two things that come into play here. Fundamental cellular design. You can have a maximum good frequency reuse, as Bob Finch mentioned earlier. But you can also optimize the network on the tried and true methods in the industry today about cell splitting and optimal coverage design based on the traffic patterns. Lastly, I want to say a word about the channelization scheme that we have deployed for the upper 700 megahertz A block. So what is currently implemented that is in production in operation in Tallahassee, Florida and Jacksonville, Florida today is the standard LTE 3GPP style NB-IoT channelization that Puloli developed for this band. This is implemented both on the endpoints as well as on the network side, obviously, for them to interoperate over the air interface. In addition to that, we often get asked about what other non-3GPP systems, some of them that Bob mentioned earlier, how can be considered. And so the couple of things I wanted to mention for this presentation today. One is to point out that NB-IoT is at 200 kilohertz at a time. So in this 1 megahertz band, 1+1, one uplink, one downlink, we could have an NB-IoT occupy parts of the system, and other parts can be occupied by another non-3GPP system. However, there's a lot of caveat there, a lot of catch there. It requires the mutual interference profile study. It requires some network design to do potentially a sectorization and adjacency considerations, as well as possibly an overlay-underlay approach as well, depending on how robust and tolerant the other system is. All of these are possibilities. So we want to say this because we get this question quite often, particularly in cases where well before NB-IoT, 3-4 years ago, decision was made to choose a particular solution, and now they wanted to consider NB-IoT into the scheme of things. How can that be accommodated? So please reach out to us. We will be happy to discuss specifics depending on your situation there. That is my main presentation. Any questions? George Lucas leads our sales, all our sales effort at Puloli. Please reach out to him. That's his contact info. And then we can also take any other Q&A after.